Hello everyone and welcome back. In this video, we're going to discuss strategies using useMemo, caching, and code splitting with lazy loading and suspense with fallback. This is part 2 of the video series, Optimization, Performance, and Scalability. And at the end of this video, I'll cover one more bonus strategy that you'll find extremely helpful when it comes to website performance. So stick around until the end. So let me just say that this is the final video in my React Redux CRUD application series, and I'm so excited that you stuck around until the end of the video series. I truly hope that something I shared with you was useful on your software development journey, especially if you're focused on front-end development. Looking ahead, I plan to continue to create videos on a range of topics like TypeScript, developing the backend with Node.js, spinning up an Express server, and using proxy URLs to resolve CORS issues. I'll also dive into how to conduct technical audits for SEO, performance, and accessibility. If you're not already subscribed to the channel, please subscribe now and push the bell notifications button so that you're alerted when my next video releases. That said, I won't be publishing on a weekly basis for now. At the end of this video, I'll explain why with a special announcement, so stay tuned for that. Now let's get into the first strategy, useMemo. useMemo is a React hook used to optimize performance by memoizing the results of an operation. In other words, it remembers the output of a function so that it doesn't need to perform that operation again unless the dependencies change. To demonstrate the benefits of useMemo in our post-based application, imagine adding a feature that allows users to search for, filter, or sort posts by criteria like author, title, or description. If you're working on a large number of posts and multiple components depend on the filtered or sorted results, handling that logic in Redux is necessary, but can be an expensive operation. Anytime data is requested or state updates, the filter and sort logic embedded in the selector or component will rerun, potentially causing unnecessary re-renders across the application. But if multiple components rely on that logic, we need to handle it in Redux. However, if only one component depends on the results of your filter or sort logic, it's best to handle that logic locally within the component using useMemo. This ensures that the filtering or sorting only reruns when its dependencies, such as post or search terms, change, and not when unrelated parts of the state updates. Let's just go and take a look at the slice so I can explain what I mean. So currently in our global state, we have entries or post entries. But let's just say we had another property that was called profile. If we change any of these profile properties and call the post object, it will cause our entire component to re-render even if we're not updating post entries. We don't want post entries to run just because we updated username or description. Using useMemo in the component ensures that such logic only runs when relevant data pertaining to entries actually change. Now we don't have this profile property in our application, so let's take it out and save it. Using useMemo locally keeps global state updates like updating a profile from affecting our components logic. And this approach minimizes unnecessary recalculations that keep our component performant. So here, let me just explain, we're selecting our post and we're not selecting the entire object. We're only selecting the part of state that we need to update our post. For example, we select entries property and we assign it to a local variable post. Over-selecting from state, such as selecting the entire post object, can trigger avoidable re-renders, which defeats the entire purpose of memoization. By narrowing the selection, you reduce re-renders. Then with useMemo, you reduce unnecessary computations within those renders, especially when filtering, mapping, or sorting data. So going down, let's paste in our search input box. And just below our use effect, we're going to include our useMemo hook. So let's set that up. And it includes a dependency here. So here we're going to filter through the post array. And we're going to check each post. I'm going to see if each post includes search term. And we are going to return those results. And here in the dependency, we're going to include posts and also the search term, because if any of these change, then we want to rerun this logic. That is, we want to filter through all the posts and check if there are posts that include the search term. And we want to store all of our findings in a variable that we're going to call filtered posts. And this is a typo, so let's correct that. And here we can go ahead and pass filtered post to the post list. So let's go back up, and here we're going to create state for search term and set search term. Use state, and we need to import that at the top, and it's going to be blank by default. So we're going to go down here and make an adjustment. I think I have set search query, and this should be search term. We're also going to edit post to include description, and off camera we edited some of the post descriptions to include flowers. And now when we go back over and we search flower, only post that include flowers shows up. Let's say we had an application with thousands of posts and we search for a term. Thanks to useMemo, the next time we search for that same term, the logic won't rerun. The result is retrieved from memory. While this is a simple example, useMemo becomes even more valuable for expensive computations. Take a mortgage calculator, for instance. The application can memorize the calculation so that on subsequent renders, the computation isn't repeated unnecessarily, improving performance and responsiveness. So the thing that you have to remember is that useMemo caches the results only during the lifetime of the component. That is, during the time that the user is still on the page. If a user leaves the page or refreshes it, the memoized results are lost. useMemo will prevent the component from rerunning the same code logic in order to produce the same result and using extra resources. So here's the thing. If you implement useMemo here in the component, then we don't need to include this logic for searching for posts in the global state. So we don't need to create a separate reducer for searching. The entire purpose of implementing it in this component is because this is really the only place that uses the search logic. So we can say that useMemo is a caching tool because it memoizes or reuses the previous results. Instead of repeating that same filter or sorting logic, useMemo will recall and reuse the same results from the previous search. So now let's talk about code splitting using lazy loading and suspense with fallback. Code splitting is a technique used to break up the application's JavaScript bundle into smaller chunks so that only the necessary parts of the code are loaded when needed. Without code splitting, when you import components in an application, they are all bundled up and loaded at the same time, whether you request or need them at the same time or not. And so if a component is large, it may slow down the performance of the entire application. This is the default behavior when loading applications. A better strategy to use when an application initially loads is to first load components based on how critical they are to the UI. Initially, that means loading components that help visitors know where they are, such as the navigation, the footer, and the home page. Next, we want to load components that are integral to the operation of the application. And these are the parts that users interact with the most, but that don't need to load immediately. So what that means is we allow the home page, the nav, and the footer to load normally based on the default behavior. And then we delay the other components from loading until they are requested by the application or a user requests them based on their interaction with the user interface. So this gives you an idea of how React Lazy or lazy loading works. And it also uses Suspense to handle the loading state while the component is being fetched. In other words, Suspense gives the user something to look at as a reassurance that it's still loading and is still working on the request. Let's implement this by heading over to Visual Studio Code, and we're going to pull up the app file. So the first thing we need to do is make sure that we have it installed. So React Lazy and Suspense are only available starting in version 16.6. Now the easiest way to check to see if you have the latest version installed is go over to your package file and just look at the React version that you have as a dependency. And I have 18.2.0, so I have a more recent version than 16. So if you don't have it installed, you just go down to the terminal and you type npm install React at latest, React at latest, and then you hit return. I already have mine installed, so I don't need to do that. So once you have it installed, you go to the top of the app.js file and you import React, Suspense, and Lazy from React. And you save it. Now we mentioned that the default behavior was to load all of these all at the same time. And we don't want the application to load by using the default behavior. We only want components to load that are necessary for the UI so that the user understands the goal of the website when the page loads. So in our case, the home page and the navigation are important for most applications. Those are the first things that users see. So let's go take a look at our application and see what else is important to running our application. So let's rerun our application. Let's clear this. npm run dev. And in our application, we have our, like I said, we have our nav and we have the home page. We also want the post list to show and each individual post. We also want this create and the search to show. That's all on the home page. So let's just take a look at that. The home page has all the necessary components that we need to run. So we have here our home page and we have our post form and the post list. So of course, going back over to our app.js, these two are the next important components that we need to show. These we want to load using the default behavior, which is, as I mentioned, everything just loads at the same time. Anything else we want to delay in loading. So that would include all the other components. And let's see, the post form needs to go back up to the top because that is a component that shows up on the home page. So the other components that are remaining are the about, contact, and edit post. These are the components that tell users where they are and what they need to do. These components are also important, but they're secondary and they're based on requests. So if a user is in a post and they want to edit it, this component would load based on the user's interaction with the edit button. And then these two components would load based on clicking a link on the navigation. So I hope this makes sense that if it's the most important, it loads first. If they're of less importance, we can delay it using React.lazy. And so now I'm going to show you how we implement that. And so the way we delay the loading of these components is we create a variable for each component. So it would be const about, then we're going to call lazy. And we're going to import. We're just going to import this same thing here. So what this does is it delays loading about. It's not going to use the default behavior. It's going to delay the loading of it. And we can just kind of get rid of it here, but I'm just going to hold it for now. We're going to also do the same thing with contact. So here we're going to call the lazy function. And we are going to import components, contact from components and contact. And then we're going to do the same thing with edit post. We're going to lazy load it. So we're going to call lazy and import the component, which is edit post. So let's save that. And so we seem to have an error here in the edit post, and we are missing the S. And now it's showing up. So all of these components and their dependencies load synchronously. They're bundled together and load when the application loads, whereas these components are not included in the main bundle. They're split into separate chunks and load asynchronously, only when requested via React.lazy. Now, we may not see the benefit of using React.lazy in this application because it's so small, but if you were working with a very large application, let's say it had 200 pages, you could improve the load time of that application by loading most pages using lazy load. And so this would reduce the initial bundle size and improve the performance of the overall application. Since we're using lazy load, we can expect a delay when these less important pages load. And during that time, we don't want to display an empty page because that wouldn't be a great user experience. Instead, we can display something like a loading spinner. To do that, we're going to use a suspense, and we can move routes in the suspense. And here we're going to call a fallback property, which we're going to include a spinner here. So I'm going to show you where we can find these spinners. Let's look up npm React loading spinner. That's what it's called. So we can use this library to find a really cool spinner. Let's go down and I'm going to show you where to find the spinners. Click here, and there are several spinners to choose from. There's circles, rings, comments, bars, triangle. Let's use this triangle, ball triangle. So you can just copy that information. Let's just go back over and I'm going to import this. Oh, I think I have to install it first. Let's install it. npm install. Then we're going to grab this line of code right here. You import the specific spinner that you want. So this one is audio, and I like the triangle spinner. So I'm going to go back over and I'm going to import React spinner, and I'm going to call the ball triangle. Then we're going to go back down here, and in the fallback, you just grab this ball triangle, just like that. And here, we're just going to add the ball triangle. And so now we're going to add like a little container for this ball triangle, and we're going to call it, we're going to have a class name for page center because we want this to be in the center of the page. And so let's restart our application. Let's clear this first. npm run dev. And so our application loads normally here. And then if we were to click the About page, it was ever so brief, but we see that the fallback UI loads. So now the user doesn't see a blank screen. So seeing that loading spinner gives them the reassurance that their request is going to be fulfilled. So before the announcement, I have one more optimization strategy that I want to share with you in this video. We just got done talking about lazy loading or delaying components that we don't need to see immediately. We can also apply the same strategy that we did with components to lazy load images only as they're needed by the application or requested by the user. So currently we don't have an image on our website, so I'm going to add one quickly and explain how to optimize it before using it on the website. So let's head back over to the application. And currently we have this image, this food image that we want to use on our home page. So let's go to that component and we're going to open up home. We can close this one here, and right above, where are we going to place? We're going to place it right above the search box. We're going to create a div here. And inside the div, we want to include an image. And we're going to have a source, and we're going to include this image here called foodie post JPEG. And we're going to also include an alt tag. This is image of in dinner. Chicken dinner. Yep. So let's save that, and let's just make sure we're able to see our chicken here on the home page. And we're going to fix the CSS later. And so normally I maintain my assets in a separate folder, so I'm going to create that here. That's going to be for images and videos and assets that I'm going to use on the website. And so if you add assets into the public folder, then you need to also add it here. So I notice it says checked here, which is not correct. So I'm just going to remove that really quick. Now, optimizing this image is a two-step process. First, we have to reduce the actual image size. And then the second thing is to delay when the image loads on a page. And both of these affect the page performance. So whether you have a small number or a large number of images in your application, you still want to optimize the images in order to improve the load time because every little bit counts. So for the first part, to reduce the image size, we're going to use a tool called Squooch. Let's go back to the browser, and the website is scooch.app. Okay, so now back over in our application, we see that our image is here and it's there. It's in the public folder. So let's just go here to the public folder and yep, there's our image. And I just want to show you the size of our image. Here it is. Currently, it is 203 kilobytes. And it's not really a large image, but I'm just going to show you that we can still improve the image, this image size. So I'm going to go back over to Squooch. So here you have the option of how you want to import the image, and I'm going to browse for it. So here we have it on the desktop, and all I need to do is either I can do it that way or I could just drop it in. Okay, so there's the image. So the first thing is to resize it. We can resize it, but the size is fine as it is. And I need to compress it to a WebP file. And we're going to improve the quality because we're going for the blue side here. So we want to improve the quality. And right now it says 75, and we could just keep moving that number up until we see the quality that we like. Somewhere between 75 and 85 is a good number. So once we have the quality that we want, we can go ahead and download the image in that format. And we're going to go over to our downloads, and then we can just move that over to the public folder in our application, assets. So now we can go back over to our application and we should see both files. And we're going to change this to the WebP file. And we can delete the JPEG file. Okay, so I just want to show you the difference. Let's go back over to assets. And this is the WebP file. The WebP file is smaller. There's not a tremendous difference, but like I said, every bit counts. And we reduced the file to 126 kilobytes, and I think it was like 203 kilobytes. So we want to go through each image and we want to reduce the size of the image, compress it as much as possible so that it's not taking up unnecessary space in the application. So let's go back over to the home page. Now the second part to optimizing images has to do with delaying or lazy loading images. And for that, we're going to use the React LazyLoadImage component library. And this ensures that images load only when they enter the user's viewport, reducing the initial load time and conserving bandwidth. This is especially helpful if you're using image galleries or content-heavy pages with blogs. Unlike React LazyLoad components, this library is not included with React 16, so we have to import it. And we need to go here to the bottom. We need to stop the application, and we're going to npm install React LazyLoadImage component. So let's let that load. And while it's loading, we're going to go to the top and we're going to import. Import LazyLoadImage from React LazyLoadImage. And so now all that we need to do is go down to where the image is located. And we're going to change this to LazyLoadImage. And save that. So now images will only load when they're in the user's viewport. That takes care of the page's performance from an image standpoint, but it's not a great user experience to see a blank space where the image is supposed to be. Because we lazy loaded the images in order to improve page performance, there may be a brief delay in seeing the image load up. And so just like when it came to using Suspense and fallback for components, LazyLoadImage has the property to help with that small delay. And that is called effect, and we assign it blur. So let's save that. So this property used along with LazyLoadImage improves the user experience by showing a smooth, visual, appealing blur placeholder while the image is loading. It's very similar to React Suspense with the fallback where you get the spinner. But in this case, you're getting the image as a blur. So using the blur effect gives users a better experience because it assures them that the image is definitely coming. So let's just move this down to the next line. And we're going to save that. So one thing I want to clarify is that using React Lazy Load Image component does not replace the first step of manually optimizing the image and compressing the image. Reducing the image file size through compression and resizing remains a critical best practice for improving the overall load time. And then React Lazy Load Image component provides optimal performance by delaying when the image loads. Using both of these strategies together improves the page performance and load time. Now let's take a look at this on the front end. We're going to restart the application, npm run dev. Okay, so this looks great. So while we're at it, the last cosmetic thing I'm going to do is quickly fix the CSS because I don't want to see this margin at the top of the page, and I need to add space below the image, and I want the layout of this form to be different. Now I'm going to move quickly through the CSS, but if you want to learn how to structure a very basic CSS file using SASS, check out my part 2 tutorial about CSS using SASS. The card is in the description above. And so now for my end of the video announcement. My good news is that I'm starting a Master of Science degree at Georgia Tech. I was admitted for this fall 2025, and I'm very, very, very excited. I think this chicken is like an appropriate image too, because I'm also nervous. I do love a challenge, a good challenge. So I am nervous but excited to accept this new challenge in order to improve my skills. That said, I'm looking forward to sharing how to integrate AI in front-end web development, as well as seeing how many other ways that it can be used. Also, I'm looking forward to building AI and machine learning models, creating intelligent systems that learn from data, taking courses on deep learning, natural language processing, as well as decision making to solve real world problems. For all of you who have stayed with me on this journey, who have watched these videos on React, Redux, CRUD applications, please stay tuned. Please subscribe to the channel because I am going to be sharing my personal journey in learning at Georgia Tech, as well as using the opportunity to help others who may be interested in pursuing more education and gain more insight into AI as well as machine learning. So until then, thank you all so much, and I'll see you in future videos.